Chapter 7, Coordinate Geometry, is a topic that will be learned by KBSM students and also KSSM Form 4 students. So first of all, you will learn divisor of line segment, or we call as ratio theorem for KBSM, and also we learn parallel lines and perpendicular lines. Okay, today we will focus on parallel lines and perpendicular lines. Okay, we will focus on the concept of the gradient of the straight line. So, okay, first of all, let's go through the topic first. Okay, you can scan the barcode and have more information, because this topic is very important in construction, especially when you want to become engineer. Okay, construction coordinate geometry is used when drawing or sketches of buildings, or maybe for those astrophysics use coordinate geometries to determine the distance between the planets. Also very useful for aviation. Okay, the use of GPS navigation application allows us to quickly and easily locate the places that we want to go. So do you know that GPS navigation uses the idea of coordinate geometry? Okay, so that means the coordinate geometry is very useful and very important in our daily life. Okay, now let's focus on parallel lines and perpendicular lines. So it is easy to find parallel lines and perpendicular lines around us. The floats separating the lanes in a swimming pool and the support structures used in construction are some of example of parallel lines and perpendicular lines. So today we want to focus on inquiry 2, which I think is very meaningful. Making and verifying conjectures about gradient of parallel and perpendicular lines. Let's focus on inquiry 2. So, okay, we are going to carry out this activity. So we have to use the GeoGebra software, draw the straight lines L1 and L2 that are parallel to each other on the Cartesian plane. And then we'll record the gradient of the straight line L1 and L2. And then we'll drag the straight line L1 and L2, and we'll observe the changes of the gradient of L1 and L2. What can you say about the relationship between the gradient of straight line L1 and L2? Measure the angles formed by the two lines. Okay. My dear students, Form 4 and Form 5 additional math students, today I would like to teach you concept of parallel lines. Okay, parallel lines. The words parallel, we have 2A and 3L. They are the same letter, 2A to 3L. So it means that same gradient. Okay. Now tangent value between the line, okay, and positive x-axis is actually represent gradient of the lines. So for Form 4 KSSM syllabus, you need to understand this concept. It means that the gradient is equal to tangent value between the line and the positive x-axis. It means the steepness of the line, okay, when we talk about gradient. In other words, we say we find the angle between the line and the positive x-axis. Okay, so tangent value also means gradient. This is very important concept. Okay, So when two lines are parallel, they are having the same gradient. Okay, and the angle between the line and the positive x-axis are the same. That means the tangent value for the angle between the line and the positive x-axis for both parallel lines are the same. This is the important concept for parallel line. So now I would like to show you the important concept. Okay, this is very important. It can be very hot. Okay, hot means you must know how to apply. So if two lines are parallel, so first of all you draw the two parallel lines, then from there you can sketch out the two right angle triangle for the two lines, and the angle between the line, okay, between the line and the positive x-axis, okay, that is the angle that we want to find the tangent value. So we just take the tangent is TOA, right? Opposite over adjacent. So opposite is 1.5, adjacent also 1.5. That means tangent theta is 1. So you shift tangent 1, so angle is 45 degree. Okay, so that means they are having the same angle. Same angle, theta 1 equal to theta 2. Both are equivalent to 45 degree. So they are actually parallel. Okay, so tangent value represent gradient of the line. So M1 equal to M2 because they are parallel lines. Okay. Now for this slide, I actually show you the tangent theta 1 is M1, tangent theta 2 is M2, and then I show to you they are having the same gradient. So the angle theta 1 equal to theta 2, therefore M1 equal to M2. Okay, so therefore for parallel line, gradient are the same, angle are the same. Okay, same steepness, right? And for activity 2, we will use GeoGebra software again. Now we will draw straight line L1 and L2, but they are perpendicular to each other on the Cartesian plane. And then we'll record the gradient of L1 and L2, and we'll determine the product of the gradient of L1 and L2. And drag the straight line L1 and L2 and observe the change in the gradient of L1 and L2 as well as the product of their gradient. What can you say about the relationship between the gradient L1 and L2? Measure the theta 1 and theta 2, the angle formed between the line L1 and L2 respectively towards positive x-axis. Very important keywords, positive x-axis. Hence, determine the product of tangent theta 1 and tangent theta 2. Okay, I just want to remind you again, it's towards positive x-axis, meaning that it is in second quadrant for the tangent value. Okay, what is the relationship between the tangent theta 1 and tangent theta 2? And you need to explain the meaning. And then, okay, we will try to show the experiment. Okay, and then afterwards I will explain to you. Okay, so when two lines are perpendicular, so the angle between the line and the positive x-axis, the theta 1 and the theta 2 line and the positive x-axis, they won't be the same. Okay, and if you find the tangent value between them, tangent theta 1 and tangent theta 2, you find the product between the two angles, it will be equal to -1. Okay, because 1 is at the first quadrant for theta 1 and for theta 2 is at the second quadrant. So tangent in second quadrant is negative. So for sure you get -1. Okay, that is the meaning of product of the two gradient for two perpendicular line must be equal to -1. Okay, and the angle here must be angle between the line and the positive x-axis. Okay, please highlight the keywords positive x-axis. Now, for this line, I show to you both lines are perpendicular, and then the theta 1 and theta 2, if you find they are not the same. So, okay, so the right angle happen at the point C, okay, and the product of the two gradient must be equal to -1, and the gradient is representing by the tangent value. So okay, again, I show you that a tangent theta 1 times tangent theta 2 is equal to -1, and theta 1 is not equal to theta 2, and the m1 times m2 must be equal to -1. So in order to find the angle, you can work out the triangle, and then you try to find the tangent value. Okay, but for tangent theta 1 is okay, you have the acute angle, but for theta 2, the angle for the line which are perpendicular is at second quadrant, but for parallel line, theta 1 is equal to theta 2, okay, because they are having the same gradient, so tangent value also the same. If they are having perpendicular to each other, then the theta 1 not equal to theta 2. Okay, because the tangent theta 1 and the tangent theta 2, when you multiply, then you will get -1. So obviously theta 1 and theta 2 for two perpendicular line won't be the same, but for parallel line they are the same. Okay, that is the conclusion.